All right, we're still finding other ways to measure spread. We want to find out how far apart the data actually is. And that's the main thing that spread does. Uh, if something has a small spread, it might have a graph like this. A large spread would have a graph like this. It's spread out quite a bit, where this one is really close together. So one way that we measure this is with variance and standard deviation. These are closely related. Variance is just the square of the standard deviation. So what we do here, to find the variance, we take each value and subtract it from the mean and square it. Add all those up and divide by one less than your data set. It looks like a very complicated formula, especially when we boil it down and we take the square root, which is what we use most often, which is the standard deviation. The standard deviation is the square root of 1 over n minus 1 times the sum of x minus x bars squared. Now that looks complicated, but let's just do that on the next data set and see what it actually looks like. So we have this data set. The first thing we need to do is find the mean. So we add up all those values. Move this off to the side a little bit. Oh. Hopefully I can move it. There we go. So we have 10 plus 12 plus 13 plus 17 plus 25 and 77, and then we're going to divide that by 5. So our mean is 15.4. So now I want to take each of these values and subtract it from 15.4, because I'll write it over here. We want to take the square root of 1 over n minus 1 times all of our x's minus our means and square it. So we found our x bar. Now let's take each of these and subtract our mean. And so 10 minus 15.4, that's negative 5.4. 12 minus 15.4 is negative 3.4. Here we have negative 2.4. And now 17 minus this will be 1.6. 25 minus this is going to be 9.6. So we have each of these values, and now we're going to square them. So if I take the, oh, I should do that for the next row. Now if I take that and I square it, x minus x bar squared, I take each of those and square it, and then I add them up. So how about I just do this part on my calculator? Now 5.4 squared is going to be the same thing as negative 5.4 squared, because a negative squared will be positive. So I'm just going to put, I forgot an addition sign in there, plus 2.4 squared plus 1.6 squared plus 9.6 squared. Now I sum all those up, and that, what I have here, 141.2, is this part of the equation. So now I have s equals the square root of 1 over something times 141.2. N minus 1. So if I have 5 data points, I'm just going to say it's 1 over 4, because that's 1 minus 5. And then now I just have to figure this out. So we take this and divide this by 4. And now I take the square root of that answer. So my standard deviation is 5.94. Now we got to think about what that means. What that means is the point varies typically about 5.94 from the mean. So if you look at it, most of the data is 5 point, or about 6 above or 6 below, except for this point. And but most of the data is around there, a typical bunch of data. Now, properties of standard deviation. It measures the spread about the mean. It should be only used when the mean is used. So that means when the um, when the distribution is symmetric, we use standard deviation. If S is 0, then there's no spread, and so all the observations are the same value. Uh, and it's not resistant, so if there's some outliers, the standard deviation gets quite high. So when picking a summary, we mentioned this before, but we use the 5-number summary for uh, for when the data is skewed. Uh, we use X bar and S when it's a symmetric distribution. Now on our calculator, it's way easier. It's really nice on our calculator. We can, first thing, let's clear out our data set. If I want to find these standard deviation, I type this data in, 10, 12, 13, 17, 25. There's a few ways you can do it. One way is if you hit second stat, the list, and go all the way to math. You can see you could find all of the things that we need. Median, standard deviation, mean. Let's look at number 7, standard deviation of L1, 5.94, and that's what we got. If we wanted to do variance, variance is just the standard deviation squared. So we can either square that, or we can hit second stat, go down to math, and number 8 is variance. So the variance of L1 is 35.3. So we would just write that S squared, 35.3. So it's good to know how to find both standard deviation and variance. Now, it's common to ask which data set has the highest standard deviation. So if you look at this, this doesn't vary very much, all that much, and neither does this, but this one varies a lot. So we say this one has the highest standard deviation. The data is the furthest from the mean. Over here, there's a data set up here that's pretty consistent. Here, there's more clumped in the middle, but this one, the data is the furthest from the mean, which is in the middle. So this one would have our highest standard deviation. All right, now here is that data set we worked with before. Try to find the standard deviation and the variance, and then decide what's more appropriate to use here, standard deviation or a 5-number summary to describe the spread. Good luck.